We good? All right. Happy Monday. It's quite the weekend. Quite the weekend. So, the marathon. It's my worst one ever, but I finished. I didn't, despite throwing up a whole lot. It was 6 hours, 2 minutes, 54 seconds. It's okay. What do you get? Thankfully, my brother was there. Walked like the last 9 miles with me. But it was done. It was fun. Atmosphere, crowd. Almost 20,000 people running. It was a lot of fun. Felt great for a while. And then my brother's car got stolen. They stopped it. So, like, 3 hours later, after checking thing at the gas station at Highland Park, all he lost was his all of them. You know, weekend. Yeah, car back. That's cool. Yeah. And he had insurance. I told me he could have a new car, but that's what I always want. So. All right. You folks doing? Have a good weekend? Doing a lot better. Back at home recovering and amazingly, body gets thrown off so easy. We're going to talk templates today. One of these days I'll figure out how all this works. I'm still new, right? All right, so we'll just add a source file to start. Now, templates are actually really interesting here. Stream, we've been using them without really realizing it. And that's kind of the fun part here. When we start to make our own templates, it starts to get really crazy. So we're going to take a look at how we've been using them first, and then we'll look at what we can do to make our own. So one of the fun ones we looked at was pair. So with a pair, you said, hey, what 2 types do I want to store in a pair here? And we use these fun greater than less than signs, or I forget whatever the term is for these here. We say, hey, I'm going to have maybe a string and then an integer. And this is my pair. So the pair is a template type because we're telling it what specific type we want to store inside of here. And you can do other fun things. So if we added a class here and said, hey, I want this to be my, oh, probably shouldn't be header. We'll call this like an item class. Again, nothing super interesting. Will be a class for item. And then we'll have our private section. We'll have our public section. I think we probably have one we can copy paste somewhere. You know, string for name, user namespace. String. All right, so string for name, and then I'll just do in for price, right? And then we'll add our constructor. So we'll have an item that takes a string for name and an in for price. And we set this name to the name, we set this price to the price. So item now is a type, right? We've written a class for it. It itself now can be used anywhere you need a type. So in my pair, maybe I had a string of pair and item, if we include item. So when it asks for a given type, we can give it one of our primitive types, like our ints and our floats and our doubles, or our characters, or string is really more of a class anyway, right? We're including the whole string class library. So we've done it with string, but it doesn't really feel like a class as much. But you can give any class that we write as a type. We say, okay, sure, here are my, I don't know, this is items. Oh, there's no, okay. If you don't have the default constructor for item, it's upset because it doesn't know how to put an item in here that we haven't specified. So that's fine. So we'll go add an items constructor here. And what do we want to do? We'll just say name is an empty string, maybe, and price 0. Then we should add some gets and sets. So a string for get name, and an int for get price. Probably shouldn't be an int for price, should it? Sorry, that should be a double. That'll be a little nicer. Get price. Everyone wants to charge pennies for things, right? I think rounding to the nearest dollar might be a little much. If we round to like the nearest nickel and got rid of pennies, we'd save a lot of money and not have to have pennies everywhere, but sure. And then set names, right? So void for set name takes a string for name, sets my name to the name. You get tired of these real fast here, I'm sorry. Price, price, this price is the price. Okay, so now we've got our default constructor. Now we can make our pair. And then items.first or item second is some particular value here, right? I don't know, apples. I don't know why we'd use the name anyway here, but we could if we wanted to. And then items.second is an item given apples and $1.99. Or we went to the orchard. They didn't go pick them off the trees because that's a little bit of a pain to get everyone out there, and then everyone complains that they're cold. So we just bought a bag that they had picked for us, which is so much nicer. But Honeycrisp apples were like $15 a bag, but they're really good apples. It was probably a good like 10 of them, and they were like bigger than my fist. These are huge apples too. So it was that's actually not too bad, right? Especially for Honeycrisp. So works out. But we can give it this particular type. Right? If we specify what the type is, we can go and use it. So this is a template type here. So what we can do is we can make our own. This is where it gets super fun. Oh, that's the wrong book, sorry. Let me go back to the library. My library. So if we look at templates here, you can make a function template to start. We'll start with function templates, and we'll get to the class templates in a minute. So I could make a function that takes a specific type here. I have a function for it. This min one is, sure, it's fine. We can start with that. So if I want to make a function that is a template type, right, we give it the template specifier and then the set of braces. Now, most of the time, I think people use T. The type's a little bit funny here, but I'll say, hey, I want a template. This is type name, capital T, type name T, and then we say what the function does. Then what we get to do here now is this T will represent whatever type they specify here. So I can say, hey, this will be, I don't know, void print smallest, given a T of first, a T of second, and a T of third. So if you give me 3 T's here, I'm going to print which one is the smallest. I don't know what T is right now, right? It's up to whoever uses this function to tell me what that T type is, just like a pair. The pair class has no idea what we're going to put in it. It just says, give me 2 things, and as long as they match, you said you wanted a string, you wanted an item, sure. You wanted a string and you wanted an integer, sure. You wanted a string and you wanted a float, sure. You wanted 2 doubles, sure. Anything that you give, as long as they match, we're going to be okay. You say, hey, if first is less than second, right, and first is less than third, print first. Oh no, sorry, see out first, maybe an end line. All right, if first isn't less than second and it's not less than third, let's check. If Hector, my friend, thank you so much for donating to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. You're a legend, my friend. So if second is less than first and second is less than third, we will see out second. And if first isn't the smallest and second isn't the smallest, probably stands to reason third would be the smallest. We can do that, right? Now, again, this function has no idea what type it's operating on. So we really hope that the less than operator works here. If I try and use this for item, it's going to be really, really, really confused because I don't know how an item is less than an item. And it doesn't know either, right? We haven't specified. We can go specify, which is really cool. We can do some operator overloading and say, hey, C++, if you want to know if an item is less than another item, I'll tell you, which is cool. We'll look at that in just a minute. But then I can use that function. I can say, hey, I want to print the smallest item given what type? How about given an integer? right? And I'll give it 3 integers then. So I can give it, how about, what 3 numbers should we give it? 3, 23, 42. Okay, so we told it, hey, function or template function, the type that you're going to use for this call will be integer. Here's 3 integers. And this works. So if I give it something that's not an integer, though, well, it should be mad at me, but it's not mad at me. Hang on. There we go. So if you give it something, because you can sort of treat a double as an int, it's bad. We shouldn't do it, but like it'll let you shoot yourself in the foot. But now it's like, oh, that doesn't work, right? No instance of function template print smallest matches the argument list of type constant character and int. Doesn't match, which is what we'd expect, right? We didn't give it the same type for all of these, but if all 3 are the proper type here, it'll work. We can give this a run. Oh. And did it print out 2 things? I didn't put that in an else. Oh my goodness. My goodness. Friends, you have to catch me when I do dumb things. You have to catch me. Now we'll try that. Now we get the 3. Okay. It was an else, but yeah. There we go. So we get the smallest number, which is kind of cool. We can also do it then, print smallest of type string, and give it 3 strings. First, second, third.
First and third.
It's not going to be by number of letters. Remember, when you compare strings, it's by the Unicode value of the letters. So if they're both letter C's to start, then you look at the second letters, then you look at the third letters, and so on. So a capital A is the smallest letter. A lowercase z is the largest letter. I think that was in Zybook somewhere. There's a link for that Unicode table. Yeah?
When passing the argument through the template, smallest, right? Till for the word default constructors, you can set like automatic values if they don't put in a value, right?
Like a default here?
Yeah, default, yeah. Could we potentially do that something like this and compare 2 items while still having
What default would you use?
value max?
Well, if I don't know what t is, I can't say like 10 because I'm specifying any given type here. And if you don't use an integer, 10 doesn't fit.
Use null.
Like a null pointer, maybe. But then you have to give it pointer types here. So generally, no. There are some ways to do it, but it gets a little complex. So if your t is a class that has a constructor, you can say, hey, I want a think like a t that way, and say, hey, let me just take the default object. Sort of works. Like, yeah. Yeah. So a lot of times people use t for template type or type name or something. So the book has the type. I don't know why, and they like putting the type here. Yeah, so it's just it's like a variable name for a class, which is a real weird way to have variable names. But it's whatever type that they specify now. This is the type variable, not a object variable. So I prefer t's because that's relatively common here. So we should see which one is the smallest. First is smallest because F is closer to the beginning of the alphabet. That's smaller. Right? Let's print smallest given a type of item here, and we'll give it how about an item. What are we going to buy? We're going to buy apples for $1.99. We're going to buy bananas for 49 cents a pound or something, and bananas. Thank you. And then we'll buy how about cucumbers for like 99 cents a pound, 99 cents each, depending which ones you get, right? Uh-oh, there's a build error. This t, excuse me, does not define this operator or a conversion to a type acceptable to the predefined operator. It doesn't know how to figure out less than, right? It can tell. So at compile time, I tried to compile here, and it says, no, the T you told me here doesn't do less than, game over, which is nice. Like, it's not a runtime, it's not going to crash while running, it won't compile. It's like, hey, I know what this code does. I know the code checks for less than. I don't find a less than. I don't see a less than. I can't do the thing you've asked me to do. So you gave me a type that's invalid here. So we could fix it if we wanted here. And honestly, I just have to go Google. Operator overload less than. I can never remember how they look. Any of these any good? This one looks okay. All right. Let's give this one a try here. And this is my item. Was it not like here now? What? Didn't find that one. No. Constant references. All right, that one didn't do what I wanted. Come on. C++.com. Here's my, operator less than. Do it here. Let's try that. Let's say an item, other. I can't find an operator less than. That's really weird. We're going to try it and see if it goes. No, it's part of our class. Right? I'm trying to say, hey, this. Okay. Sorry. The semicolon, I think, threw it off. I think that was what it was. Because it looked more like a definition, not like a header item. So, okay. For the operator less than, right, returns a Boolean, true or false. If we are less than, so this is my instance is less than a reference to another instance here. So how do we want to define less than? Do we want to compare name? Do we want to compare price? Probably just price. Yeah, we'll say the cheapest thing is less than, right? So we can return my price is less than other.price, right? My price compared to other price. If my price is less than the other price, that's true. I'm returning true. I am less than the other. If my price is not less than, I'm going to return a false. I am not less than the other. Does that make sense? Right. So now we should be able to run our program and see. Oh, come on. Right hand operand of type T. Oh, we can't see out it now. That's right. That's the next step. So now it has no idea how to see out this sort of thing. Okay. Again, I'm just going to Google here because I can never remember these sort of things. C++. Class. See out. I'm losing our right terms here. See out in the class. This one here. You need an operator, double arrows. All right, here we go. Here we go. So to make that one work, we're going to add a definition for the operator double arrow. And then this is void doesn't return anything. This is a type of item. Too many for to be able to see out first, because it does says I don't know how to see out at first, right? I don't have a arrow operator, which takes a right hand operand of type T. So it's like yeah, similar. Yep. Too many parameters for this. I think we need to include IO stream. No? This one? Ah, oh, okay, so stream operator, arrow, arrow, given a stream, given an item, item. No, we're close. We're real close. This one, do we need it? Ah, okay, I think this one will do it for us. Not a semicolon. So given an output stream and a particular item, we will send the item through. I think we need to give it this way. The friend designation here is weird because it's going to give access to the object here that we normally wouldn't have. It's sort of a funny way of adding this in here. Yeah, friend need to be item. So no, I think this is the right one here. Anonymous meow. So then we're going to take that stream and we're going to add my, this is probably item. And maybe we'll say, how about name, colon, and then item.name, and then price, colon, and item.price. Should we add a $, make it look pretty? All right, cool. And then I think we need to return. Do we have to return? I think we have to return it because we're expecting to get back the operating stream or output stream. That way you can say, hey, take an output stream, send something to it, send something else to that output stream. Like we're just kind of chunking all these things in together here to make a chain of them. I think that'll work for us. Give it a try. It worked. That was very exciting. We can Google better than the average bear. You guys are way too kind to me. Way too kind. So we found the least item, right, which we defined as the smallest price. Sorry, my triggers. Something is unhappy. Too high. So for all of that to work then, right, we needed to add some other things. So the operator, you can overload any operator. You can define, hey, I want to figure out how I add one item with another item. Doesn't really make a lot of sense for us to do that, but we could. Sure. We could say, hey, I want to be able to multiply items. Again, really weird, but if your class should be able to do arithmetic operations, sure, let's go for it. Right? If we wanted to write a class that represents a polynomial, you can add polynomials, you can subtract polynomials, right? I think you guys are pretty good at that by the point of you are in calculus, right? I would hope. Sure, so we could define any of these operators here. So whichever ones are useful for you, go for it. This output stream operator stuff, this one's a little weird, but this is really nice for if someone wants to send your class right to the output stream. Yeah.
Why does it need to be a friend function?
The friend function gives it additional access. I think if we don't have it, yeah, if we don't have it, it's unhappy.
But it's defined within the class. Oh, does it need to be a friend to always?
I think because the output stream is the friend to it. This stuff that part always confuses me. Class that can access the private and protected members of the class. So it's a weird access distinction to say, hey, we're going to give you access you normally wouldn't have. But in this case, output stream needs to get these values here.
So that's why people sometimes friend for the output stream and a separate part. And they,
yeah, you could define it else like. I threw everything in the H file because I'm lazy, so that's probably my fault here. Yeah, so you can define it elsewhere, but this is.
The workplace, do they care?
Different places have different standards for how they want things done. So the reason H files are bad is the bigger your project gets, anytime you include an H file, it's essentially copy pasting it in. So if you change something, any other class that uses it also needs to get recompiled. So if you have a class that's used in like 50 different places and you change it once in an H file, those other 50 things have to get recompiled for it to work. If you use a CPP file that references the header file, if the header file doesn't change, you can just change your CPP file and that's perfectly fine because that will get compiled separately. And then anything that references the H file, when it goes and uses it, goes and gets that correct version that was compiled. So for what we're doing in our class, it doesn't matter at all because everything's super fast anyway. Like if we have to compile 4 classes, we don't care. If you have to compile 1,500 classes because you're working on some large enterprise project, it'll really slow things down. So again, there are ways to do this. We're just being lazy because it makes life easier for us to just put it in an H file. My apologies. I'm probably teaching you a bad habit, and I'm sorry, but it makes it easier and faster for us, and it just makes us all happy. Okay. So template, right? This is our template function here. So it allows you to, hey, sure, you tell me what type, I'll go do it. Now, if it doesn't match, right, we saw it wouldn't even compile if it doesn't have these right operators, which is nice. Right? We probably shouldn't do things we're not allowed to do or it doesn't understand how to do. And you can do, and the IntelliSense is really cool. You can give it template arguments and all sorts of other fun stuff, but that's nice. So we can write individual functions for templates, or we can write classes that are templates, and that's where these like pairs and things come into play. Like, these are individual classes essentially that are templates. So the entire class then can work on a given template type. So we're going to add another item here, and we'll add a header file. We'll just call this, I don't know, how about a bag? Say using namespace standard. There we go. We want to include, I don't know what we want to include, IOStream for now. We'll see. We'll have our class for bag. And now we are going to be a template class at this point here. So let me go down to this next section so I can copy paste out of our book. So we say, hey, we are a template class in here. So like we put the template above the function before. Now the template goes above the class definition here. And it has a private and a public section. So this bag then can hold so many items, right? So we'll have a T first item, we'll have a T second item, we'll have a T third item, something like that, right? We can throw things in the bag. Sure. We could make it a magic bag if we wanted. This will be a bag of holding. So a common magic item in D&D, because why not? So we can just drop as many things as we want in here. We'll ignore physics. Say it's a magical bag, just throw stuff in. Okay. So what we're going to have then is a place we can store as many things as we want to here. How about like a vector, right? We can just keep on pushing back. Eventually it might run out of space, but we're not going to add bazillions of items, right? We don't have time for that. But now I can make a vector of type T given my bag. So vector can take the template type here as its type. Because eventually, when we create this bag of holding, we'll tell it what type it is. When we tell bag of holding what type it is, it'll tell the vector what type it is. It'll get a type eventually. So we can make a constructor for bag of holding here. And we'll take our bag. Actually, it's just there, right? I don't think we need to do a whole lot with it. Probably don't need our constructor, right? How about add an item? We add item. So what, and that's a void function here. So what is the type of item that we're going to add to our bag here? Type is T, right? So whatever thing we're going to give it here, this is the item, we'll go and add. So we'll take our bag and we'll push back the item. Whatever type we specified this bag to hold, hey, you're going to hold a bunch of these things, go for it. We'll throw it in our vector of this type here. Right? And then we can have a T value that is the return type. We say get item. Now the fun thing with these is you're just going to get back a random item. You stick your hand in and something comes out. Maybe it's a rabbit and you're a magician. I don't know, maybe it's the thing you were trying to get. Doesn't exactly work, but we're just trying to have some fun. So to get a random item out, right, we need to go get a random item out of that bag, out of the vector here. So I probably need to know the size. I mean, you can get a random index, right? So if we get a int for random index, that's going to be math dot, is it just random? Just random. Modulus my bag dot size. Just rand. Thank you. Rand, yeah, rand. Modulus the bag size. So if I have 10 things in my bag, right, random number modulus 10 will give me 0 through 9. That's a valid index. So I can return my bag dot at random index. Here, now you got a random item out of the bag. Throw a bunch of anything you want in here and ask for something, I'll give you a random value. Not a very useful bag here, but sure. So this is a templated class of any given type. So hey, I'm going to give you a bunch of the type of item. Why not? So in my main method over here, then I can make a bag. Oh, we got to include that, don't we? Include our bag. Holding, we'll call it a bag. Bag. Did I spell it wrong? Oh, I have to tell it what type. Sorry. Bag of holding of type. How about item? So we're going to throw a bunch of items inside of this. Again, it could be integers, it could be doubles, it could be strings, but usually it's more fun to do things with your own classes. Right, so we can add a bunch of things. We'll take our bag and we'll bag dot bag of holding. Must have class type name. Give it the wrong thing. I think you gave it the right thing. Bag holding. Why is it unhappy now? Do I not need that? Okay, sorry. We didn't have a constructor call. I need parentheses. So we can add an item or we can get an item. So let's add. You want to add apples, bananas, and cucumbers again? We'll add apples. Bag add bananas, bag add cucumbers. Sure. And then we can see out a bag.get item. Should give us a random item, right? Because that's what we wrote it to do. Right, we got the cucumbers that time. If I run it again, we got cucumbers again. Okay, let's run it again. Got cucumbers again. Run it again. Cucumbers again. We're not getting a very good random seed, are we? I really did. Yeah. Wow. Yep. Yeah. I went a marathon yesterday. I didn't run the whole thing. I'm a little tired today. Thank you for bearing with me. Yeah, so we could go and seed our random value based on the time. What is that, the srand or something in here? Right. Our bag class. Srand of time or something like that. That sounds right. Give it a random value. Does that look ring any bells? Yeah. Okay. Some folks might have seen that. Oh no, build errors. But not. No, Art, is it not time? No. Time of null? Time of null. Hey, now we got some of those. Now we got bananas out. We got bananas out. Cucumbers out. Trying to get the apples. Apples. All right. So it works here. So what this one's doing here, it's giving us a new random seed, right? This srand gives random seed value random. Because remember, computers can't actually be random because they literally do what we tell it to do. So it has no way of actually being random. So what it does is it takes some particular value and does a bunch of math stuff behind the scenes that I don't understand to generate a random value. And then the next time a different random value, next time a different random value. That's all based on the seed value. So if you give it a seed based on like, hey, what the current time is, this is pretty common because every time you run your program, it should be a different time, right? Because by the time I click now and the time I click the next time, the time will be different. So this will essentially give us a random value here. Otherwise, it's the same sequence of random values every time because it uses the exact same seed. So that's a helpful little pointer here. We didn't have to Google that one, did we? You guys helped. You helped. Can I give credit to you guys? I can't remember anything. Okay, that's fine. All right, so that's our template class then, right? We'll take of a given type and it can do something with it, which is kind of fun. It's building our own mapping. Wow, that sounds like a big pain. We can build our own map. Yeah, good. So this is going to feel really weird for a while. Once we start talking about linked lists, we're going to use our own template class to build a linked list. Because the idea here is it can hold anything, just like a vector can hold anything. Our linked list can hold any type you give it. That bag of holding can hold any type you give it here. Which is pretty fun. So it's very flexible in that it allows other people to use our class in ways that they want to. So I'm not saying, hey, the only thing you can ever add is integers, or the only thing you can ever add is floats, right? It allows them to use whatever type they want to use, essentially in our, what we call these data structures. It's ways of holding data in memory. How am I structuring the data so that I have access to it? Right? How am I going to store all this stuff in memory? I don't think we're going to need Wednesday for this, which is good. So we can start linked lists on Wednesday. And that'll leave the 26th then to go over project 2 and talk about project 3, so we don't run out of time again. Because talking about a project, talking about new stuff, and then talking about a project, I ran out of time. That was poor planning. But we got to the project in lab. Hopefully everyone got it. It made sense. Our checkered project using recursion, checker calculator, max jump calculator, right? The project.
Correct.
Are you messing with me? The project we talked about in lab for project 2?
Last line?
Yeah.
Oh, wasn't there?
That's why. Okay, that makes a lot of sense. We ran out of time to talk about it in class. So I talked about it in lab. It's all posted in Canvas though. Really, my kids I mess with my kids all the time, so now they mess with me all the time, and now no one believes anyone when we say stuff, which is fair. I suppose that's fair. Yeah, so these are super cool because we can have a generic type here. Oh, we can actually probably start. We got enough time to start linked. So do you want to be done now, or do you want to start linked lists? I can go either direction. Whatever you guys want to vote on. We can talk about the project again. Yeah, that's fine. That's good. All right, project 2, then is our recursion project. We are building a checker jump calculator that will calculate the maximum amount of jumps for the white player. Right, with checkers, you have black checkers and you have white checkers, or any different words, white checkers and black checkers, to make our life easy here. So given a board of a vector of characters, right, an 8x8 board, saying here's where all the checkers are on the board. I'll give you a B if it's a black checker, I'll give you a double if it's a white checker, I'll give you a space if there's no checker. Right, I'll give you a board. You go figure out what is the maximum number of jumps I can make for any one of my checkers. You don't even have to tell me which one it is. Like, I can probably figure that out. Oh, maybe I can figure that out. Yeah. I'm sorry? So we're going to assume every piece on the board is a king, so it can go forward and backwards. Otherwise, it gets more complex, and then you'd have to have like white king and regular white. So we're practicing the recursion here, not necessarily practicing how checkers works. Checkers is just the vehicle for us to practice some recursion here. So right, you jump over pieces. So we're going to need to be changing the board because pieces come off the board and the white checker moves around the board as we go. Right? So for any given white checker, so we need to test all of them, see what is the most number of jumps we can get on our turn. Right? Yeah. So we have our constructor, we have our white checkers, we have our black checkers. Well, get max jumps just returns the single integer value of maximum number of jumps a white king checker can make on the given board. Hey, thanks for following along.
The king checker is
Yeah, so we're going to pretend every piece on the board is a king because it'll make our life easier. And we don't really care about checkers. So the idea is we're going to be using backtracking recursion for this, like we did for the Sudoku solver, like we did for the maze solver in lab. It's simple backtracking recursion, right? So you get 5 points for your checker class with private attributes and a constructor. You can get 5 points if it doesn't work at all. All you need is the class. You get 5 points, right? If it will work at least once with backtracking recursion to find a sequence of jumps, you get 5 more points. If it actually finds the longest possible jump, if it works properly, you get your last 5 points. So if you give me something like slightly functional, you can still get 10 out of 15 points. That's not a great score, but you can get some points. I want to. Ideally, everyone turns in a working project, but I haven't had that happen yet. So everyone turns stuff in usually, but not everyone turns in a project that works. And I get it; things happen. Like I've got a busy life too, and I wait till the last minute for all sorts of things that I shouldn't. But I have to evaluate things. That's kind of why it's a college class, right? Like they pay me to stand up here and talk, but they also or sit here and talk, but they also pay me to like grade your stuff. That's really the main focus because that's how higher education works. Because we're weird like that, and you have to have someone who's considered an expert say whether or not you did it right or wrong. I guess that sort of makes sense. It's a weird system. It's a really weird system. So 10 out of 15 if you just get some backtracking recursion working in your class and can figure out one series of jumps. Fantastic. But if it actually works, then you can get all your points here, is the goal. Right? So when we looked at the maze solver, right, we said, hey, we're going to drop some breadcrumbs here to make sure I didn't walk on top of a path and get an infinite loop here. Okay? There's no infinite loop if you're taking black checkers off the board. If you don't take black checkers off the board, I brought my tablet. I'm so excited. I can plug this in here. This thing is amazing. I used to have a laptop I could draw on. I don't have that anymore, and I'm sad. But they didn't last very long. So I'm hoping this tablet lasts long. I can draw on blank document here. Let's see, will it write? Will it write for me? So, right, if we have a little checkerboard here, right, I'm not going to put all the checkers on, but if we just have a couple checkers here, right? If we have a white checker here and a black checker here, right? Your first jump, you would jump over, and the white checker goes here. It's removed. Where's my erase? Oh, erase. There it is. It's erased from there. You also need to take off the black checker because otherwise, when you get to here and you recurse and you say, hey, how many jumps can I make? It says, oh, I can jump over here. Let's jump over here. And then erase my white checker over here. Right? So that what happens on the board when you jump is the white checker has to move. Back to draw mode. There we go. And then the black checker has to come off. And the white checker has to come off. Right? And we looked at like a longer sequence if we actually had a larger board, right? That's 8 by 8 here. I don't know if we'll get all 8, but we'll get a couple more. That's like 7, sure. That's probably close. And we looked at a couple different sequences of places you could jump. Right, and so white pieces can't jump over other white pieces. They can only jump over black pieces. But if I had a black piece here, I don't know, black piece here, a black piece here, a black piece here, black piece here, sure, maybe black here, black piece here, right? The idea is you could jump all the way over. You could jump to here. Oh no, that was a eraser. Undo. There we go. It's a really cool thing. I have to make sure I use it right. Right, we could jump to here, and we could jump to here, we could jump to here, jump to here, we could jump to here. Sure. Right, all sorts of different jumps we have going on. Right. Yeah, 1, 2, 3, 4, 5. Yep. But if we didn't do all those jumps, and maybe we had a different arrangement of checkers. Nope, undo. Go back to pen mode. There it goes. So if we had, say, a white checker over here and a white checker over here and a black checker here and maybe a black checker over here and black checker over here, right? White could go this direction for one jump, or it could go this direction for two jumps, right? Or maybe if there was another black checker here, right, it could go two jumps that way or two jumps this way. Still, the longest possible number sequence of jumps is two jumps. We don't care which path it happened to take. We just say, hey, the most jumps you can get is two. You don't even have to tell me what it was. Just say this was the most number of jumps you can make on your turn, right? But if this white checker goes, right, it could go 1, 2, 3. The longest path isn't 2 because this white checker can jump to here and then jump to here and then jump to here. So the sequence of events, making sure we put the board back to the way it was when we're done, is important. That undo step, right? We did the Sudoku solver. We said, hey, if I got stuck, I tried a 1, I tried a 2, I tried a 3. Okay, I tried the 3, and then I tried another move and tried another move. Eventually, that one dead ended. Right? Take that move back off the board. Take that move back off the board, and then let's try the 4. We'll try the 5. We'll try the 6. We'll try the 7. Once we got stuck there, take that move off the board. Go back to where we were here. Right? And what's nice is recursion tracks a lot of that for us. Right? We said, hey, C++ will remember I called the function solve at this location. Here was the row, here's the column. Or I forget how I think that's what we did with maze solver. I said try row column. That's usually easiest with the row and column. With Sudoku is just find the next number. Right? We found the next open space to try. So that backtracking recursion will say, okay, hey, what white checker, where did I start? So we had, so what is this? So 0, 1, 2, 3, 4, 5, 6, and 0, 1, 2, 3, 4, 5. Look at that, I drew a 7x7 board. I'm really good at drawing things. Right, so if we tried this first checker, we'd say, okay, we're at row 4, column 2. So we're trying jump at 4, 2. Right? Now, you just do the series of steps. That's the maze solver said, try up, try down, try left, try right. Didn't really matter which order we tried them, and it was fine. So we're going to try jumping, diagonal, 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 diagonal. Hopefully you name them better than diagonal, diagonal 1, diagonal, like diagonal 1 is terrible. Right? You can name them better, but it's going to try each of those directions, right? Boop, 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 boop. It tries this one, tries this one, tries this one. Okay, we went this direction, sure. Right, now we're going to jump from, now whatever we're at, I don't know, like 6, 1. We didn't actually do a jump, maybe like 6, 0. Pretend we jumped over here, if there's a black checker. Right, we would jump over here. When this one is done, I have no other jumps to do, right? This one comes off the call stack. We come right back to where we were at this code, trying this diagonal jump. So undo what you did, put the board back, right? Make sure your white checker is gone. Right? We jumped, we got stuck, so we had to undo. So put the black checker back, put the white checker back. Make sure you clear that one off too, right? And we can keep on trying the next direction, the next direction, the next direction. Once we get to dead end, great, we'll go back to the previous function call. Right? And all of this is tracking the longest jump as we go. Pen mode, there, longest jump. Oh man, my handwriting's terrible. It says longest jump there. Just trust me. Does that make sense? Checkers? Okay, so this is just some basic backtracking recursion. This is perfectly fine for a standard checkerboard. If you wanted to do something really, really, really large, it would just run forever. And backtracking recursion is not the ideal solution for that sort of thing, but it's a simple way for us to kind of understand and practice the recursion, and you can learn the really fast ways in other classes. Okay? We good? Cool. Got anything else? We good to be done, or do you want to start linked lists? I could probably wait till Wednesday, right?
Yeah.
Okay, sounds good to me. All right, thanks, folks. I'll see you Wednesday.